just read through this real quick, make sure you can see it from where you're at. A translation or a slide is an isometry that maps all the points of a figure the same distance in the same direction. Thus you can use a vector to describe the translation. Using the diagram below, a translation described by v prime is a transformation that maps point A onto A prime, that the following are true. Boy, I did not read that well, or I didn't write it well. Let me read that again. Using the diagram below, a translation described by v prime is a transformation that maps point A to A prime, that the following are true. Okay. Well, let's pause a second. I left the word "so" out of the statement, so that's why it was hard for me to read and understand what I was saying. Using the diagram below, a translation described by v prime is a transformation that maps point A to A prime so that the following are true. A prime, V is a parallelogram if A, V, and V prime are non-collinear, and A prime equals V prime, and AV equals A prime, V prime, if AV and V prime are collinear. So if they're all on the same line, then this statement would be true. If they're not on the same line, then this figure is going to be a parallelogram. Okay? And the two pictures below then are trying to support option 1 right here is this picture, and option 2 right here is this picture. Okay? Let's look at what we're saying right here. Oops, sorry. I have the marker on. A prime, V prime, V. So A, sorry, I went the wrong way. A prime, V prime, V. That is a parallelogram if these 3 points, A, V, and V prime, are not all on the same line. Okay? That makes a parallelogram. So what we're saying, these right here represent our vectors. We're sliding A to this spot, and we're sliding V to this spot. Though they have the same vector. Kayla, would you rather explain this for us? And listen. They have the same vector. They have the same direction and the same distance. We can get there by using coordinates, like in the coordinate plane, the xy axis, remember that? If this was, say, 5 units to the right, and this was 1 unit up, then that vector would be represented by 5 over and 1 up. It'd be right here. Now I can take that vector, yeah, it will, and I can move it wherever I want. You notice it still has the same slope to it, doesn't it? And that's what's happening here. This vector, I won't be able to I can't just grab one of these and move it because the whole thing is pasted together, grouped together. But if I highlight this, okay? So this vector right here then is exactly the same as that vector. And if I moved it over here and moved some other point, it would be exactly the same. Okay? And before the day's over, we'll describe that vector as coordinates. Also, another way of doing it. Okay? But it's very important to remember that it's very important to remember that if you're translating a figure by a vector, you're moving every point in that figure exactly the same distance in the same direction as each of the other points. And so that's what's happening here. We moved A and we moved v by this vector right here. And when we moved a, we got a prime, and when we moved v, we got v prime. Now we did the same thing over here. We have the same vector going on here. So you see a was moved to where a prime is, and v was moved to where v prime is. Okay? But a, v, and a prime are all, or a, v, and v prime are all on the same line. Actually, a prime is also. And so in this case, we're not making a parallelogram because we had our two original points were on the same line of the vector. Okay? In the coordinate plane, recall that you can use an ordered pair for a vector. Now, I say recall because originally we taught this chapter last. That's not really true yet. You don't have the background of this I was telling you yesterday. The symbolism that looks like this means vector notation. So if I put 3, 2 in here, I don't mean plot the point 3, 2. I mean we're moving everything 3 units right and 2 units up. So this symbolism, where we have kind of a V-shaped parenthesis as opposed to these parentheses, this symbolism means all you have is the point 3, 2 on the coordinate plane. Where this means I'm moving everything 3 units up and, try it again, 3 units right and 2 units up. So in the notation, x represents the horizontal change and y represents the vertical change from the initial point to the terminal point. Another phrase we hadn't talked about yet. This would be my initial point, and this would be my terminal point. The very tip of the arrow of the vector represents the terminal point. The tail end of the vector, just the non-arrowed end, represents the initial point. Okay? So if I took this point and wanted to move it by that vector, I would simply slide that vector over here, and at the end of it would become the new point, the terminal point. Now, if I knew that vector was represented by 3, 2, 3 right and 2 up, then on my coordinate plane instead I could count 3, 1, 2, 3, and go up 2, and I get to the same point. Okay? So two different ways to represent a translation. One is with a vector, and one is with vector notation on the coordinate plane. Do we have any questions on what I'm trying to remind you of here? Remind is to those who worked on it yesterday. Any questions for those who weren't here yesterday? Have I lost anybody? Anybody not done with this page? Okay, let me pause it. A composition of transformations is a combination of 2 or more transformations. In a composition, each transformation is performed on the image of the preceding transformation. In general, the composition of any 2 translations is a translation. Okay, so in the homework, they ask you to do a few of these. Example 3 explains it a little bit. So if you're confused when I'm done, then look through example 3. If you're still confused, raise your hand, and we'll come back and try to address it again. What they try to show you here is that we can write triangle ABC as a matrix. The top row would represent all the x values of the ordered pairs. The bottom row would represent all the y values of the ordered pair. So if I want to write point A, which is intended to be right on that intersection of the grid lines, not just slightly to the left of it. What would the coordinates of A be? -5, -2. So the x-coordinate is -5, so that goes on top, and the y-coordinate -2 goes on the bottom. What's B? -1, 1. And so the x-coordinate goes on top, the y-coordinate goes on the bottom. What's C? 2, -2. And so on top I put 2, and on the bottom I put -2. Okay? Now, the translation matrix that represents this vector has to have exactly the same number of elements in it as this matrix. So this matrix is a 2 by 3. 2 rows by 3 columns. Matrices are always given in dimensions of rows by columns. And so 2 by 3 means 2 rows, and 3 means 3 columns. Okay? And so how many total elements are there in this 2 by 3? 6. Okay? So that means my translation matrix has to have exactly the same dimensions, 2 by 3, has to have exactly the same number of elements. And so the difference is we're translating all the x's by 3, so I need to put 3's on all the top values. We're translating all the y's by 5, so I need to put 5 on all the y values. Okay? And so if I rewrite that, -5, -2, -1, 1, 2, -2. Translation means I'm going to add this to my translation matrix, which was 3, 3, 3, 5, 5, 5. And then my result is going to be what I get when I add those. So what we do to add is we take all the elements that are in the same location. So this is in row 1, column 1. So I add that to this row 1, column 1. I get -5 plus 3 is what? -2. Then I do the same thing with the next one. Row 1, column 2 with row 1, column 2. What do I get? -1 plus 3 is 2. And then the next one would be what?
5.
Yeah, how'd I get it though?
You did row 1, column 3.
Nice. Row 1, column 3. I like the terminology.
And then row 1.
With row 1, column 3, and what do I get? 2 plus 3 is
5.
5. And so when I do the same thing with the bottom row, row 2, column 1, row 2, column 2, row 2, column 3, Hunter, I don't know where Dalton came from. Hunter, what do I get for the first element here?
3.
3. -2 and 5 is 3. And Jeffrey, what do I get the second one?
6.
Because 1 and 5 is 6. And the last one? Someone new? 3. -2 plus 5 is 3. And so this matrix represents the translation of this matrix. And so that means the coordinates of A prime are going to be -2, 3. The coordinates of B prime are going to be 2, 6. And the coordinates of C prime are going to be 5, 3. And so I could plot that if I wanted to. -2, 3. Well, this is in my way again. 2, 6, and 5, 3, and so I get this triangle, which was A prime, B prime, C prime. Okay? Now, again, this is example 3 in the work. If you have more trouble with that, let me know. I'm going to stop.